All right, we're going to be trying another one of these two sample hypothesis tests based on proportions. This one's going to be dealing with never married individuals. In a recent year, the U.S. Census reported that 32.6% of men aged 15 or and older had never married. The percentage of women that would never married for the same age group was 25.6. Okay, interesting. Based on the data below, can it be concluded that the percentage of never married men is greater than the proportion of never married women? All right, so since we're doing this based on the information on the data below, whoops, did not want to use that. Let's try that again. There we go. That means all that stuff they gave us at the beginning, we don't need that. One thing that's always good to know, what do you need, what don't you need? So we're doing this just based on the data below. They're just using this to set up the problem. We are not even going to deal with that. So these are our samples. We've got men and women. All right, so this is going to be nice since we have some different letters going on here. I'm going to go with P of M and P of W here. Makes it nice and easy, men and women. All right, so I'm going to establish my null and my alternate hypothesis. Remember, your null is always equals. Something equals. I'm going to go with proportion of men equals proportion of women. Excellent. And we established that we're looking at proportion never married. We have it all up here. I could write it out, but again, since I have this information, proportion of men never married, I'm just going to use what I've got, right? Proportion of women never married. You have the information, just use it, right? Okay. Now, for our alternate here. In some cases, we've done two-sided tests where we're just proving that there's a difference. What we're looking for in this case is specifically that men is greater than the proportion of never married women. Never married men is greater than the proportion of never married women. So I'm going to do proportion of men is greater than the proportion of women. P of M is greater than P of W. This is going to make it a one-sided test in this case. All right, so what do we have to do? Conditions, let's check them out. Random. Is it random? Let's check it out. Based on the data below. Let's see, they did some data here. A recent year. They don't say whether it's random or not. It's always good to check that, but they don't tell us. So since it's based on the World Almanac, tell you what, it was a sample by the World Almanac. We're going to say yes. Assume yes. Because World Almanac. Because it's a pretty reputable source. If you're ever in doubt, right, if they don't mention it, but you have a source, like in this case we have the World Almanac, then you say yes because we assume that a group like that should do a random sample. If not, then we put the blame on them because you notice how we put World Almanac here. All right, so then we want 10%. All right, so let's see. We've got 300 in each case. It's 300 less than or equal to 10% of, instead of unmarried, I'm going to put never married men. I think it is quite safe to say that 300 is definitely going to be less than 10% of all never married men. Let's see. And our second sample here for the women was 300 as well. So we're going to say 300 is less than or equal to 1/10 of never married women. That's very safe to say. So we're covered. 10% rocking. Good. Now our last condition, large counts. Whoops, did not want to do that. So let's see what we're looking at here. For the men, we've got 99. 99, is that greater than or equal to 10? Certainly is. But you also have to check what you would consider a failure. In this case, 99 out of 300 are never married, so we're going to say that whatever's left, 300 minus 99, that should also be greater than or equal to 10. I think we can safely say that. We're in good shape. And I'm even going to put down here men, just so I have that handy. And then let's check the women. All right, 81. 81. Is that greater than 10? Certainly is, but we're not done. We also have to check to see that those who have been married, 300 minus 81, that's still greater than 10. We're in good shape. So again, the key is you have to check your conditions for both samples. And then the samples are based on two different populations. You have to check it for both. Okay, so what am I going to do now? I'm going to do a two-prop z-test because it's based on proportions. How do I do that? I'm going to go to my calculator. Let's see, I have men is 99 and women is 81. I'm just checking the order here. Okay. So I still have some data left for my last one. Again, you go to stat, you go to tests, and you're going to go to two-prop z-test right here. Now let's see, we had 99 out of 300, and also we had 81 out of 300. And now, what are we trying to prove? We're trying to prove that, I think we're trying to prove that men are greater than women in this case. We are. So, since I entered in men first, I'm going to go back to my calculator. We are going to try and prove that P1 is greater than P2. Now, I have a couple of options here. I can either do calculate or draw. I'm going to do draw this time. And you notice I got some other stuff going on in here. Well, if you do draw on your calculator, you should be getting something. Mine is not giving me one. Again, I think it's because I'm using a different format calculator. I don't have the benefits that you guys do. However, it looks like I got the results of my two-prop z-test right here. I'm going to take a picture of it and save it. And pull it in. Again, these are the pieces of information you really want in there. Now, it has P1, P2, P3. So let's see. We'll go with what we need. Let's try that again. Turn one photo. There we go. Slide that down. Come on. There we go. Now we're in business. Shrink it down a little bit. All right. So now let's take a look at our p-value. Our p-value, the thing we're really concerned with here for this hypothesis test. You always want to have your z anyway, so always write that test statistic. But these are the two things you really want to pull from this. Your z and your p-value. My p-value in this case is 0.054. That is really close. So I'm going to put that down here. P-value. 0.054. Remember, your significance level is always 0.05. So let's see. Our p-value in this case, it is greater than our significance level, 0.05. So what does that tell us? That means we do not have enough evidence to reject our null. Remember, it has to be less than your p-value to reject the null hypothesis. Once again, we have a situation here where we fail to reject it. So since, whoops, that looks awful. Let me fix that. P-value 0.054. Again, it's really close, but it's not quite there. Is greater than. We fail to reject our null. We do not have enough evidence to prove. Now, before I jump to this, I'm going to go back up to my null and alternate here. Again, you're trying to prove the alternate. In this case, we're trying to prove that the proportion of men is greater than women. We did not prove that today. So, for my final statement, we do not have enough evidence to prove that the proportion of men is greater than the proportion of women. All right. So I wanted to go through a one-sided test with you again for two samples, just setting up the null and the alternate here. Null always equals. Since it was one side this time, we used an inequality. Our conditions, again, you did it for both of our samples here. And then we ran our two-prop z-test, which is what you're going to be doing today. All right. So, again, if you have any questions, you can shoot me an email. You can either post it on Schoology 2 if you're one of my students. If you're not one of my students, you can email me at statscom